All right, here we are, lesson 3. And we're looking at the probability of compound events in lesson 3. More specifically, we're going to start to learn about what is called a tree diagram. So, this is our introduction that we're going to start with. So, let's take a look. Amy wants to pack enough items to create 6 different outfits. She packs 1 jacket, 3 shirts, and 2 pairs of jeans. Can Amy create 6 different outfits from her clothing items? So number 1 says complete the table below. So outfit number 1, she's got her 1 jacket that she's packed. Now she's packed 3 shirts. So this is saying that she can wear shirt number 1 with the jacket. And then remember, she packed 2 pairs of jeans. So this is saying she can wear the first pair of jeans with this outfit. So the jacket, shirt number 1, jeans number 1. Her second outfit, she can wear that jacket again because remember, she only packed 1 jacket. She can also wear shirt number 1, but then she can wear that with the second pair of jeans, jeans number 2. So there's her second outfit, jacket, shirt 1, jeans 2. Number 3, third outfit she can wear. She can wear the jacket, she can wear shirt number 2, and then she can wear that with the first pair of jeans, jeans 1. Fourth outfit. So let's fill in what's missing here. She can wear the jacket, she can wear shirt number 2, and she is going to be able to pair that with jeans number 2. So the second pair of jeans that she's packing. Jacket, shirt 2, jeans 2. Fifth outfit, okay? She can wear the jacket, she can wear the third shirt that she packed, and she can pair that with the first pair of jeans. So jeans number 1. And lastly, outfit number 6. She can wear that jacket, she can wear shirt number 3, and she can wear the second pair of jeans with that. So jeans 2. Okay, so there's her 6 outfits that she can wear based on what she's packing. So number 2 says the table is an example of an organized list. What is another way to show the different outfits that Amy can create? So absolutely, right? In this table, you were able to see how many outfits and you were able to list everything that she's packing. And so that's just organizing yourself and how many outfits you can come up with. So what we're going to learn about is tree diagrams. And what that's going to be is a picture, a model of really this organized list. And so you'll see why it's called a tree specifically diagram, because it kind of mimics that a little bit. It looks like the trunk of a tree and some branches, but it's exactly how it sounds, meaning we're going to be able to draw a picture of how we can put outfits together or other situations. So number 3 says, describe another situation for which you might want to list all possible outcomes. Okay, so I love my ice cream. So let's talk about an ice cream shop. Let's say you go to, Frosty O, and you're trying to decide if you want a cup or a cone, comma. So you get to Frosty Oasis. Do I want a cup or do I want a cone? And then let's say you get to choose between chocolate or vanilla, or let's say strawberry ice cream, comma. So cup or cone, chocolate or vanilla or strawberry ice cream. And then lastly, your topping. So, let's see. Sprinkles or maybe some chopped nuts on it. So, cup or cone, chocolate or vanilla or strawberry ice cream, toppings, sprinkles, or nuts. And so that's just one example, right? Like you could create an organized list in a table, like what happened in number 1 here. But as well, the next thing I'm going to show you is how you can also take this and make a tree diagram. Okay, so anywhere along the way when we're working on any of the math work in the book, if you need to pause and catch up, please do so. And then you can just meet me back here anytime, right? So we're going to go to the next page at this point. And the next page is page 734. All right, finding a sample space. So a sample space right here, this definition, it's the set of all possible outcomes in a probability experiment. And so for you to look at a sample space, you can use organized lists, you can use tables, you can use these tree diagrams to represent your sample space. So let's look at a couple of examples here. Now, number 1, it's going to show you how to just list it again. So if you have 3 students chosen to represent Mr. Baldrick's class in a school assembly, and you see the students over here in the table on the right, Adrian, Carlos, and Greg, and all 3 of them need to sit in a row on the stage. So use a list to find the sample space for the different ways they can sit in a row. So all 3 of the students have to sit in a row right on the stage somewhere. And so what they're going to ask you to do or show you here, just to abbreviate and make it a little easier, you can use A for Adrian, C for Carlos, and G for Greg, and use the letter only once. So that means, okay, they listed it for you. So let's take a look at this. In that row on the stage, Adrian could sit first. There's the A. Carlos, C, could sit next to her. And then Greg, represented by G, could sit next to Carlos. So Adrian, Carlos, Greg. That's one way that they could sit on the stage. Let's look at a second way. Adrian also could go first, right? Be the first one sitting there. And now Greg is sitting next to her. And then Carlos. Adrian, Greg, Carlos. The second way that that can look. Okay, another possibility. Carlos could sit first on the stage and then have Adrian next to him and then Greg. Carlos could sit first on the stage, but then have Greg next to him and then Adrian on the end. Fifth way, Greg could sit first and then Adrian and then Carlos. And the last way that you could have that sample space for the 6th one, Greg could sit first, then Carlos, and then Adrian. So there is 6 different ways the 3 students can sit in a row on the stage. So the sample space consists of 6 outcomes right here. There's 6 ways that that can happen. Now that's just, again, an organized list, a way to do it. Now, number 2. This is going to look a little different, right? So now we're going to start talking about your tree diagrams. A car can be purchased in blue, silver, red, or purple. It also comes as a convertible or a hardtop. Use a table or a tree diagram to find the sample space for the different styles in which the car can be purchased. So actually it shows you both, right? Over on the left here is a table. And you'll see the colors are listed of the car that you can get, blue, silver, red, or purple. And then next to that, the different kind of top you can get on the car. So a convertible top or a hard top. So in the table here, right, you can see one possible outcome is you buy a blue car that's a convertible. Second outcome, you can buy a blue car that has a hard top on it. Third outcome, you can buy a silver car that's a convertible. Fourth outcome, silver car that has a hard top, and continue on down. Again, that's a table, one way of representing it. Now, the tree diagram, how this works. So when I said the tree diagram, it sounds like, it's going to look like what it sounds, I guess, in some respects, meaning you're going to have a trunk of a tree. So you're going to take the colors of the car here, the blue, silver, red, and purple, and you list those as the trunk of your tree. because those are the different colors you can buy. You start with that. Then what you do is you take a look at, okay, you have convertible or hardtop. Okay, there's two choices there. So since there's two choices there, you're going to draw two branches from that part of the tree and list the kind of tops. So when I draw the two branches, I can write convertible and hardtop. And then over here, you're going to see the sample space. So what this means is you can buy the blue car, and I follow that branch that has a convertible top. And so all I did in the sample space is just write the initials, right? B for blue, C for convertible. You can get a blue car, follow the tree branch. That is a hardtop. And so it's a blue hardtop, blue H. So it's matching exactly what is in this table. It just looks like a diagram. It's a tree diagram, just a different way of representing the sample space. Silver car, convertible, SC. Silver car, hardtop, SH, and so on. So if you count 1, 2, 3, 4, 5, 6, 7, 8, there's 8 possible outcomes in the tree diagram. And if I come back to the table over here on the left, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 here as well. So you get the same number of outcomes. There's just two different ways to represent it. So the table, we looked at a listing in example number 1, and now this tree diagram. So letter A. Let's try this out. The table shows the sandwich choices for a picnic. Find the sample space using a list, table, or tree diagram for a sandwich consisting of one type of meat and one type of bread. So in the table here, you see you have two choices of meat, ham and turkey, and you have 3 choices of bread, rye, sourdough, and white. So I'm going to get you going on learning how to do the tree diagrams. We're going to use this green note space on the left here to start drawing this out. So I'm going to draw the trunk of the tree, which means I'm going to start here with the meat selections. So when I do this, I put down my choices as the trunk of my tree. So over here, I'm going to put ham, and I'm just going to leave a little space here, turkey. Okay, those are my 2 choices of meat that I can get. Now, when I go and look at the bread again, there's 3 choices. So now this becomes the branches of the tree. I need to draw 3 branches from each of my meat selections. So from ham, I'm going to draw 1, 2, 3 branches. And what I'm going to do here is list my 3 choices of bread. So rye, sourdough, and white. Now I'm going to do the exact same thing for turkey, right? So if I choose to have a turkey sandwich instead, I'm going to draw my 3 branches and put the same 3 bread choices there. So rye, sourdough again, and white. Now I'm going to look at my sample space, which means how many possible sandwiches can I choose from? How many outcomes are there? So I'm going to start with the ham, and I'm going to follow the branch, and I can get a ham and rye sandwich. So I'll write it out like this. If you wanted to, you could put HR to represent ham and rye. I can have a ham and sourdough. So I'm just going to list it. Ham, sourdough sandwich. Another outcome I can have is ham and white bread. So far, I can get 3 different sandwiches with the ham as my main, as the meat on the sandwich. Then go to turkey. You can get a turkey sandwich and with rye bread. You can get turkey And I'm going to follow that branch, sourdough. And then you can also get a turkey and white. So that allows 1, 2, 3, 4, 5, 6 outcomes, or 6 different sandwiches. There's 6 possible in that sample space of sandwiches that you can get for a picnic. Okay. Again, if you need to pause to catch up, by all means, please do so. But we're going to keep practicing these tree diagrams. Okay, so when you're ready, we're going to come down and we're actually going to go to letter B. So we're going to come down to bottom of page 735. Okay, let's practice another tree diagram. So the got it, letter B. The animal shelter has both male and female Labrador retrievers. So I'm going to actually underline that because these are 2 choices that we can start with. Either we want a male Labrador or a female. And those Labrador retrievers come in yellow, brown, or black. And I'm also going to underline that because those are 3 choices of color of dog that you can pick. Then it says there's an equal number of each kind. What is the probability of choosing a female yellow lab retriever? So I'm going to underline that in red, only because that's the question that we're going to find once we create the tree diagram. We want to know what the probability is of getting that female yellow Labrador. Okay, so let's start with the trunk of the tree. Now that's going to be what's first listed here. So male and female Labrador retrievers. So you're going to see me write for the trunk of the tree, male and female. And I always leave a little space because when you go to make now the branches of the tree, depending on how many branches you have to draw, that's going to space things out a little bit and you'll need that space. So if I go back here, it says yellow, brown, or black, right? Those are the 3 color dogs we can get. So that means just like what we did in the previous one, we had to draw 3 branches from that trunk for both the male and the female, because you have those color choices for both. And so now let's start to list those. So you can have with the male retriever, yellow, brown, or black. And so you see it takes a little space here, right? So now we're going to come down to the female and do the same thing. You can get a female lab that's yellow, brown, or black. So those are all my possibilities in the story. Now it's a matter of just listing the outcomes. So I'm going to abbreviate this time instead of writing everything out. You can get a male yellow Labrador Retriever, MY. You can get a male brown retriever. Now I'm going to put capital B and a lowercase r because we have 2 colors here that start with B. So male and brown. You can get a male and a black. So BL for black. So there's 3 choices of males that you can get. Females, right? Same thing. Look at the outcomes. You can get a female yellow lab. You can get a female brown lab. And you can also get a female black lab. So another 3 choices for a total of 6. 1, 2, 3, 4, 5, 6. So you have 6 possibilities, 6 outcomes. of the kind of dog you want, the kind of Labrador Retriever that you want. Now, there is one other question here, right? So we created the sample space. We see the tree diagram. We were able to see how many outcomes. And now it's saying, what's the probability? What is the probability of choosing a female yellow Labrador Retriever? So that means you're looking in your outcomes here. And where you see female yellow Labrador right here, circle it, that is 1 out of 6 choices. So the probability of choosing a female yellow Labrador Retriever is 1. Oops, that color is not great. Let's try red. So you can get 1 out of 6. That is your probability. That answers your question. The probability of choosing that female yellow Labrador Retriever, 1 out of 6 right here. Okay. So you had to do one extra step here, right? We created the tree diagram, we looked at the outcomes, but then we had to answer that question on finding the probability within our sample space. You have 1 choice out of 6 to get that female yellow. Okay, so let's keep trying. Let's keep practicing. So again, I'm skipping some because I'm focusing on just the tree diagrams right now. We're going to look at guided practice, which is on page 736. And let's look at number 1 and number 2. For each situation, find the sample space. Now, when it says find the sample space, you can create a list if you want to. You can create a table if you want to. That is totally fine because you're creating a sample space as long as you can find and list all the possible outcomes. The tree diagram is the other option, right? So I am going to show this one also with a tree diagram. Now, here with a coin, number 1, it's going to be tossed twice. So here's what I want you to think about. The first coin number 1, the first toss on that coin, your possibilities are getting heads and tails, right? So on that first toss, here's what you could see. You could see heads, you could see tails. Now, that's the first toss. Second toss, right? Because it's going to get tossed twice, which means if you're going to toss it again and there's only 2 possibilities on a coin, you're drawing 2 branches from each of that trunk of the tree. So, what can you get when you toss it again for a second time? Well, you can get heads and you can get tails. You can get heads and you can get tails, right? So this will probably make more sense when I start to show you the outcomes. So here's what you can see. First toss is a heads, follow that branch. The second toss is a heads. So you could get heads and heads both times when you toss the coin. First toss could be heads, follow the branch. The second toss could be tails. So you could get a heads, tails combination when you toss the coin twice. Heads first, then tails. Okay, this time, let's say on the first toss, you get tails. So you could have first toss tails, follow the branch, and the second toss could be heads. And lastly, that first toss could be tails, follow the branch. The second toss could also be tails. So you have 1, 2, 3, 4 possible outcomes, 4 outcomes that you could see when tossing a coin twice. Heads, 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 tails, tails, heads, tails, tails. Let's try another one. Let's try number 2. A pair of brown or black sandals are available in sizes 7, 8, or 9. So you start the trunk of your tree with what's listed first, your choices listed first. Brown or black sandals. So I'm going to start the trunk of my tree. I'm going to put BR for brown and BL for black, brown and black. Those are your two sandal choices. Now, the sizes you can get those in, there's 1, 2, 3 different sizes, 7, 8, or 9. So draw three branches from the color choices of your sandals. Again, the trunk of your tree is your first set of choices, brown or black sandals. Then the tree branches are coming from what you have to choose from next. There are 3 different sizes, so that's why we're drawing 3 branches from each one. And we're going to list them. 7, 8, 9. 7, 8, 9. Okay. So now when we write our sample space and basically list on what we can get, we're going to see we can get a brown sandal, follow the branch, that's a size 7. You can get a brown sandal, follow the branch again, that's a size 8. Brown sandal, that's a size 9. So you have 3 choices with a brown sandal and sizes. Okay, go to the black sandal. You can get a black sandal in a size 7, black sandal in a size 8, and a black sandal in a size 9. So another 3 choices for a total of 1, 2, 3, 4, 5, 6 outcomes. 6 possible outcomes. And again, like I said in the directions, you could create a table and you could list them. I end up listing them anyways after the tree diagram is drawn because you're looking to see how many possible outcomes you need to be able to count those at the end. Okay. So I think I'm going to have you, let's see here if there's one that you can try. So we're going to go to independent practice. So page 737. Let's see here. I think I'm going to have you try to start with, try number 3. See if you can draw a tree diagram. So the directions say for each situation, find the sample space. Try drawing that tree diagram knowing you have purple, green, black, or silver for your choices of a bike color. And then you can get it, that bike, in a 10, 18, 21, or 24 speed. So see what you can do with this. See if you can create the tree diagram. See if you can count the number of outcomes. And then, so pause the video, try it out, meet you back. Okay, let's take a look. The one thing about this book, unfortunately, is sometimes you just don't have a ton of space where you need it. So you can see my tree diagram is crammed in there. So let's talk about this and let's see how yours matches up and how you did. So you're going to take the colors of the bike, and that's the trunk of your tree. So the purple, the green, the black, and the silver, right? Those are your 4 choices of colors. Now you also have 4 choices of the type of speed you want on the bike. And so from each color, you're going to draw 4 branches, just like you see shown. And then you're going to list, right? So now let's talk about the outcomes that you're going to see. So I'm going to list that sample space over here. You can get a purple bike that has a 10 speed. You can get a purple bike that is in 18 speed. Purple bike that is 21, and a purple bike that is 24, right? So just with the purple bike, you can get 4 different kinds with that purple bike. Do the same thing for each color, right? So green, 10, green, 18, green, 21, green, 24, okay? So if you haven't done this yet, list. So you're just going to see me list them right now. Okay, just like that. So there's all your possible outcomes with the bikes. So count and see. 4, another 4 is 8, 12, 16. You have 16 possible outcomes here. 16 with the choice of that bike. There they are. Okay, so that was a big one. And so hopefully you did decent, if not great. But make sure, right, if you're still kind of stuck, you can go back, right? Go back in the video, take a peek again, or just, I don't know, you can even contact one of us if you're still not sure. But I'm going to do a couple more with you. So we're going to end here in just a minute, but I want to come back up and let's take a look at number 1. Let's talk about this spinner here and tossing a coin. So number 1 says tossing a coin and spinning the spinner at the right, just like I said. So I'm just underlining what you have to focus on. Tossing a coin, spinner at the right. So tossing a coin, we got to find the sample space. We're going to create that tree diagram. If you toss a coin, you're going to get heads or tails, right? So those are the two possibilities when you toss a coin. That is the trunk of your tree. The spinner, there's 5 sections on that spinner. So since there's 5 sections on that spinner, from each heads or tails, you have to draw 5 branches. 1, 2, 3, 4, 5. Just like that. And then you're going to start listing. Now I'm just going to do the numbers here. So you could land on 1, 2, 3, 4, 5. 1, 2. So on my branches, I'm just listing what it can land on the spinner. And so now if you think about your sample space, how many possible outcomes? Heads in 1, heads in 2. I'm just going to list them. Heads in 3, heads in 4, heads in 5, and then do the same thing with tails, right? You follow the branches all the way through, just like that. So there's 5 possibilities here with heads in the spinner, 5 possibilities here with tails in the spinner, for a total of 10 outcomes here in number 1. 10. Okay. All right. So we're going to stop with the book. And I'm going to have you, like I said, go into Google Classroom for 7th grade math and go to quizzes. So I only have one there listed. So I'm actually going to bring the quizzes up and show you. So for example, in question number 1, you're going to have a picture of a tree diagram, and it's going to show you outcomes of rolling a die and flipping a coin. And here it is. And you're going to look at how many total outcomes there are. So you'll see 6 numbers on the cube, right? Heads or tails on the coin. And so when you look at how many total outcomes there are, you're counting at the end. 1, 2. So you can get a 1 on the number cube and heads, 1 on the number cube and tails. There's 2 possibilities there. 2 on the number cube heads, 2 on the number cube and tails. So when your tree diagram is drawn, you can count just the ends of those branches, and that'll tell you how many outcomes you have. So 2, 4, 6, 8, 10, 12. There will be 12 outcomes on that tree diagram. Okay. So really what you're doing here in the quiz is you're looking at the tree diagrams that are already drawn, and you're going to find the probabilities, or you're going to read and see how many outcomes there are. So let's talk about this one really quick. The tree diagram shows the outcomes of rolling a die, again, 6-sided, and flipping a coin. What is the probability of rolling an even number and flipping heads? So look at your even numbers. 2, 4, and 6, right? Those are the even numbers you're going to focus on. And flipping heads. So you can roll a 2 in heads, you can roll a 4 in heads, and you can roll a 6 in heads. So that's 1, 2, 3 possibilities out of We just a few minutes ago counted 12 total outcomes. So 3 out of 12. Now here on these, some are reduced, some aren't. This one's not, so you would choose 3 out of 12, because otherwise if you reduced it, it should be 1/4. So if you don't see the reduced version, go ahead and just choose the fraction that you see, not simplified, and so on. So again, you're going to do this in Google Classroom for 7th grade math to finish out your hour today. And then coming back here, that'll be it. So we will continue tree diagrams. We'll get into lesson 5 in the next couple days as well, and tie those 2 lessons together. So have a great Tuesday, and we'll see you back on Thursday in video.